Dear, dear, dear. Why did I let you start? Tell me again why I did that.
You know, this is what we're about. Welcome to another episode of In the Mood for HTTP. What number is this, Daryl?
I believe this is season 2, episode 7.
Season 2, episode 7, and as promised, we are continuing with the zaniness and continuing with the lively discussion on all things HTTP. Okay, yes. Daryl, why don't you take it away and tell us about things other than GraphQL?
Well, in an attempt to be a little bit organized, we have our repeating pattern of the week this week, and this one is a better choice, because I know last time you kind of stumped me with, can you give examples of where this thing is actually used? And I failed miserably. And guess what? I still haven't had a chance to go and find someone who's using the whack-a-mole pattern, which we discussed on last episode.
You know, my day job is a product manager, right? So it's my job to think about little things like value and who's actually doing this and things like that.
Make the lives of developers hard.
Right.
Yes. So this week's pattern of the week is Miniput. So this one actually was this was conceived a very long time ago, actually, back in the days of the very first RESTfest. And the idea is that with the HTTP method put, you are supposed to do complete replacements of a resource. But sometimes people don't want to change an entire resource. They want to only change one field or maybe a couple of fields within the entire resource. And the idea of Miniput is working around that by creating a new mini resource that represents just one property or maybe just a subset of a larger resource. So we're just creating a special small resource so that we can change one part of some other resource. And that is the Miniput pattern. We'll add a link into the HTTP In the Mood for HTTP Twitter account and on the Slack channel. So I have a little bit more writing on that idea. But solving partial updates. And I believe, Glenn, you had a sponsorship announcement for us.
Oh, yes, I did. Thank you. Our sponsor today is Auth0 Extend. Auth0 Extend is an embedded SaaS customization platform. Using Auth0 Extend, you can make it really easy for your customers, sales engineers, and partners to add new capabilities to your SaaS. Extend is powering organizations like Schneider and Factory4, dramatically reducing the time to deliver value to customers. You can find out more at auth0.com/extend.
You're getting good at that, Glenn.
Yeah,
you must have been having practice.
I have been having some practice.
That's awesome. Awesome. So I know this is called In the Mood for HTTP, but sometimes it feels like in the mood for Daryl to rant about whatever problem he's run into this last week with regards to HTTP.
I think we should change the name. It's Car Talk HTTP.
Yeah, I don't know.
Maybe. No, I don't want to change it. I don't really want to change the name, but I actually do think we have that kibitzing. You know, that's a big part of what we do. There's the actual value in terms of the topics we talk about, and then there's the meta manner of how we talk about it.
You mean we hope there's value in the topics we talk about?
Well, yeah, exactly. That's true.
Right. Too. Right. So this is a little rant about status codes. And one of the complaints that you see regularly about status code is they're not nearly descriptive enough. And the standard answer to that is, well, yes, okay, because you can put a payload along with the response to describe the response in a lot more detail. And we finally have a standard for that, which is Mark Nottingham's HTTP problem, and it's now in RFC 7807. But that's not what I'm talking about. What I want to talk about a little bit more is status codes and the fact that the reason why they aren't that descriptive is because they aren't really supposed to tell you what went wrong. What they're supposed to do is to tell the client what it should do about what went wrong. So let's think of some examples, right? We've got 400. So what is it telling you? It's telling you, well, you made a mistake in sending the request. fix it, and try again. Which isn't very helpful because it's not very specific. So then we have a bunch of more specific ones that's like 401, which is go and fix your credentials, right? Because you made a mistake somewhere, either in your username, your password, your token has expired, something like that. So it's like, go fix it, and we're telling you specific what it is you need to fix. Let's take 403. It's forbidden. But what it really means is you don't have sufficient permissions. Go get yourself some more permissions. 404, go fix your URL because your URL is wrong because you had tried to address something that doesn't exist. 405, which is method not allowed, which means go fix your method. You used a method that was wrong. I'm getting to a point here, but I came up with all these examples. So 406, go fix your accept header. 500 range. So you get a 500 error. It's basically, it's not your mistake. We screwed up. Call support because we really made a mess if you get a 500. 503 is server unavailable. So, well, first of all, check your internet connection. Make sure you still got an internet connection. And then wait a bit. If you still have an internet connection, wait a bit. Maybe we'll get our server back up and running again. And if it still doesn't work after a little while, then call support. And I can go on, right? Like even on the positive side, the success code's 200. Fine. We did it. You don't need to do anything, right? Just there's some results relating to what you asked us for. 201 is save this URL that we've given you in the location header because if you want to see the thing that I just created for you, there it is.
I just want to weigh in. 201 is one of my favorite status codes, and I think one of the ones that the general mass of developers often don't understand the semantics of, particularly around the status monitor, which to be fair is not.
That's 202.
202, sorry, 202,
yes.
Not 201. 202, accepted. Yeah, apologies. 202. Can we edit? Yeah, I was just doing recording training. You can edit, cut it. There's no editing here. It's live.
There's no editing.
But 202.
We don't make mistakes.
Yeah, I love it's 202. I think the semantics of 201 and the location header, I think, is often also something that a lot of developers don't know about. But the 202 semantics, which really lends itself well for an asynchronous kind of world, I think is that is really one of my favorites.
Yeah. And I believe I ranted a fair amount about that last week because that was issue of the week in the previous episode. So then let me get to the point of this whole conversation. Is what people often do is they look at the status code and they look at the description of it and they go, that description sounds a little bit like the description of what it is that the problem I'm having. So they try and match the what they call the reason phrase that's associated to the status code to the problem that they're trying to describe. But that's the wrong way about it because the reason phrase is one thing. It's what the client is supposed to do about it that is important. So we ran into an issue this week. I saw a name shall be withheld. Somebody had a problem and they were returning a status code. Previously, they were returning a 500 error. And this wasn't really a 500 error. It should have been a 400 class error. And there was a particular header that caused some routing to happen on the back end. And if that header was invalid, it ended up with the routing not happening properly. So they saw status code 421, which is misdirected request. And they said, well, misdirected request sounds very much like this problem because I have this header that's doing some internal routing and it's not able us to do the routing. So we'll just reuse 421 because that is the closest descriptive thing to the problem we're trying to solve.
Right, but semantics may be different, and
because if you look at 420, so 421 is a new status code introduced in HTTP 2, and it solves a very specific problem. Because in HTTP 2 we hold connections open for much longer because there's all sorts of advantages to holding.
Optimization.
Yes. Yeah. And I don't know whether it's specifically related to HTTP 2 or some of the new stuff they've introduced in HTTPS, but what can end up happening is a request where there's a kind of a load balancing scenario on the back end can end up going to a server that doesn't have the exact same HTTPS setup as the client does. So the server cannot actually handle that request because of the HTTPS configuration. So it returns back that 421. Now, the way to solve the problem is you just drop the connection and reopen the connection.
Sure.
Right. And when you reopen the connection, you will negotiate back with the server that has all the appropriate setup. So here's where the problem comes is I'm writing HTTP client libraries and I see, oh, this server is returning 421 requests. Oh, I can handle that automatically. We already have client libraries that will automatically handle redirect requests for us. It'll automatically handle rate limiting, automatically handle long-running requests, 202s, and things like that. So why not write a little piece of middleware that sees a 421, and then when the 421 happens, it goes, oh, well, I know to solve this problem, all I do is just drop the connection, reestablish the connection, reissue the request, and the client application developer doesn't have to
even know about it. Sure.
Doesn't even know that 421 happened and everybody's happy. Until you use the 421 for the wrong purpose.
Right, because then that middleware will incorrectly deal with the response. And,
well, it will reestablish a connection, issue the request again.
Connection. Yes,
and
which will cause a failure. Yeah.
Yeah. So there's other ones that I see happening, 412 preconditional request, which is all about being able to preconditional. That sounds wrong. Hold on a second. I wrote in my notes preconditional request. What's the 417, Glenn? 417. No, sorry, 412. Precondition failed.
Yep.
All right.
Isn't that
people look at that.
Isn't it 409 though? Also.
409 is conflict. That's what you get.
That's conflict for concurrency. Yeah.
Yes, updates, and it's very specifically related to e-tags. So again, people use these conflicts sometimes for different purposes.
Yes.
And sometimes you can.
Right.
Sometimes you can't. So really the important thing is not to look at that description, but to look at what is the expected behavior of the client.
Yeah, I mean, I think I've seen, like when I worked at Splunk, for example, we had a lot of APIs, and sometimes I think this happens. People look at a description like, hey, this looks as close as possible, or the other one is, oh, let's just do 500. Let's just do 500. We don't know what it is. 500, it's safe.
Or the large multinational corporation that decided to return 209 for all of their errors, but we won't talk about those.
No, do you work for that corporation?
No. Fortunately, I don't. I do
have a meta question, which is, so I agree with you. I think middleware certainly can help here. I think there's an education thing. How many developers? This is another. We were talking about like 202, but if you were to ask the average developer, I think there's probably a handful of status codes they know and want to know. Like 404, they know because their browser is always giving them 404. They know 500. They know 200. 201 maybe. 202 less likely. But
right. But see,
409 probably not.
Yeah, but the thing is, my guess, taking 421 as an example, is I bet you no application developer ever has to issue a 421. I bet you it's server code and deep down in the guts of the HTTP2 stack where that's going to happen, which makes it all the more important why we write client-side middleware that handles 421s so that people actually writing applications don't have to worry.
Well, I would go even further and say like middleware like that could also put safeguards in place that, if an application tried to, you could have a middleware on the reverse that would throw an exception if the application developer returned to 421. That would be a different.
That's kind of hard to do, right? Yeah. Like, how do we know who set that status code?
Yeah, I guess that's true. It would have to be higher level up the stack. But yeah, it's an interesting. I do think that's a tricky place for a lot of people, or even not understanding that. Hey, I really should use a 202, but I'll just use a 200, for example, because I can get away with 200 doing anything. And then instead of using the location header, I just return you some type of payload and create all these extra semantics that I don't need to because it's already baked in to HTTP. I do have one question, though, related to this, and I've been patiently, if you can believe I can be patient, thinking about this since we started this conversation. So the reason phrase, is that meant to be modified? Or is that really meant to be the static message that is associated with the status code? Because a lot of frameworks allow you to change it. And I think I've seen places where it has been changed.
Yeah.
But I've always wondered, and I guess even though I've read the entire HTTP spec, this part I missed.
Yes. It says you can modify it, and I always thought, oh, that's kind of cool. You can modify it for custom purposes. But apparently the primary reason for allowing it to be modified is just for language.
Internationalization. That's what I was thinking. You literally are hitting on why I wanted to have this conversation.
Yeah.
Because that was the one place where I was like, yes, but even when you do internationalization, it should be the internationalized version of the English phrase, right?
Yes.
Shouldn't just be an arbitrary, because I have seen cases where it was arbitrarily changed, you know.
And the problem is, the risk again is all of a sudden there are different expectations and clients. The point of why status codes are so limited in their expressiveness is so that people can write reusable middleware, reusable intermediaries that actually act upon those to take that work away from the application developer. And if you start changing the meaning of them, then you break everything and you lose the ability.
Agreed. But where you get into problems, I think, and that's why I brought this up, is, you know, like even when you talk about internationalization, there's no one library out there across different languages that is going to know that, you know, 400 in Chinese is this, in Mandarin, or this or that. But is what you're saying is it's not necessarily that the messages have to all match exactly, but the meaning of those messages, so that if a human being reads them,
yes,
it's not about a machine. It's not about a machine reading that message. It's about a human being reading that message and knowing that the semantics have not been changed based on the translation. But it does raise an interesting question of why aren't there are there internationalization libraries, so that, you know, if I am supporting different languages, most likely I don't want a dynamic code. I don't want to have to write code that says, oh, I'm in this language, so return this message. So I just wonder, like, and if not, then why even expose that? Why don't frameworks just, I mean, I know this gets into an interesting debate, right? Of like, hey, give me access, and we went through this when we were building Web API, right? Give me access to everything the spec says I should have, get out of my way. And then there's in doing that, do you open the door for people to shoot themselves in the foot? And what is that balance? Or how do you make it so that maybe as library authors, you have kind of the, you know, easy path, which is opinionated and does a whole bunch of things for you. And then you have the kind of advanced path when you want to go outside of that to really take control. And I know this is a big can of worms I'm opening, but I think it constantly comes up, particularly when we think about HTTP, because HTTP is still, like, HTML is not foreign. HTTP still has very foreign aspects. And this, I was...
And there's a lot of history to it and legacy in it. And I'm not sure of this, but I suspect HTTP2 actually just threw away the recent phrase. I don't even think it's there.
Oh, so just go with the status code.
I need to confirm that, because, again, it is one of those things that you're not supposed to change. It's supposed to be just human readable. And if HTTP2 is a binary protocol, so you can't human read the protocol going over the wire anyway. So you need some kind of interpreter to interpret it. So therefore, a client tool can just put a human readable associated tag in whatever language is the UI language of the tool that corresponds to the appropriate status code. So I think it's just kind of one of those legacy things. But you bring up a really good, bigger issue with regards to, you know, how much HTTP guts should we let people access, and how much should we expect to know? And I've sort of had a bit of a change of heart.
Oh my God! I'm thinking back to our API. Was it API Strat? We had that big round table on SDKs. But go ahead. Sorry.
Oh no, that was API Craft in Detroit.
API Craft.
Yes, yes. See, I have always maintained that the solution to a lot of our problems in network computing is having developers who understand HTTP better and use it better. Because I've seen a lot of the problems with people doing weird things with broken abstractions over HTTP.
I built some of those broken abstractions. I left them, but I started on building those broken abstractions.
And I think I've sort of come to terms with the fact that lots of people who really don't care and don't need to care, and perhaps
we need a trumpet that we can play on demand on this show, like
perhaps they shouldn't have to care, and perhaps we can build the people who do care, build the libraries that do the HTTP right, so the application developers can just focus on doing the right thing within their application. And I think it maybe our problem is just we just have crappy HTTP wrapper tools, and we need to write better tools so people can actually do HTTP the right way without necessarily having to know all about it.
We are 100% in agreement. This is a rare moment. We can play another trumpet. We are 100% agreement on this one. I'm sure we will disagree in 2 minutes, so the show doesn't have to end, because this show is not about you and me and agreeing. But I totally agree with you. I think, and even when we get into the hypermedia discussion, it's the same thing. It's like, I don't think developers care in the sense, many developers don't have a problem. It's if you make my life more difficult and I have to worry about a whole bunch of things, and if there's so many rules, and it's like, even when you look at what it takes to build an HTTP server to the spec, and it's like painful.
Oh yeah. Yeah,
it is really painful. And what was that? I forget, back in the day, there was that effort to build like that state machine.
Yeah, HTTP machine.
Jim Weber. Yeah, exactly. Yeah, it's not easy. And anybody who says it is just lying.
Yeah, so I think there's definitely the possibility to build valid abstractions over. One thing I think that was sort of a clinching, we always go back to RPC, right? And RPC was the Uber abstraction over back-end calls. And the big problem with RPC as an abstraction is it makes remote calls look like local calls. And then all of a sudden you have this problem of, well, I don't know whether I'm making a remote call or a local call. And obviously the latency of a remote call is massively different than a local call.
Sure.
And I think a lot of the patterns that have developed over the last number of years in the Microsoft world with async await and callbacks in some of the other languages, now all of a sudden we have a language mechanism to describe calls that are long running.
Sure.
And we're explicit. So there is a distinct difference between short calls and long calls in our programming language. So there's not that same fear of, oh, you're abstracting away a network call and all of a sudden we'll have performance problems, because async await allows you to actually represent that in your language.
Yeah. I mean, I think it started with just the pure callbacks approach, that really just giving some kudos. I mean, Node was really early on, Node.js, on pushing that paradigm. And then, of course, and then on the Microsoft side, of course, you had tasks. But Node, one difference I think about Node was that they made it really central from the get-go, whereas tasks was more something that was layered on and started to get support in different places.
Yeah.
And then it's just really cool too, just talking about it, to see the organic exchange, because how, async await came to C#. Now I'm literally using versions of Node where I'm writing awaits. But I think you're right. Yeah. I mean, and why? Because it's like that made life easy. It's a complex problem under the hood, but it made it so that I, as a developer, don't have to really care about it. And the same kind of pushback, by the way, you got in the .NET world around tasks. I mean, the thing with callbacks is they were complicated, but it was like in your face, and it was like, whereas tasks brought a whole bunch of in the name of simplicity, a whole bunch of complexity in the name of simplicity.
Yeah, and developers are still struggling with it, but I mean, we're definitely making progress, and there's definitely developers are getting used to this idea of dealing with quick tasks, quick things, and long things. So let me bring this long. See, you thought we were just going to be like 30 seconds on status codes, right? We managed to drag it out for like 20 minutes. I would like to end this status code discussion with a question for you, Glenn. Do you know what the 205?
I have no idea. Zero idea.
So this is a really interesting example.
Is that in the original HTTP spec, or is that a later? Okay.
Yep.
It's important to mention that these codes do evolve.
Yep. And I believe 205 is implemented by the browser, but it is an excellent example of the fact that status codes are all about telling the client what they should do.
I just want to mention something. One advantage we have of being a video production is you can actually share the browser. And I'm going to do that for something else. So when we mention things like 205,
yes,
maybe going forward, we just show the page where it's described.
Okay, we can do that. I mean, I just go to the IANA status registry. That's what I search. I just Bing for IANA status registry.
I know. This is like incremental improvements of how we do our production.
So 205 is reset content, and it is used primarily to reset the fields in a HTML form. So when you submit a form, the server accepts data and then sends back a 205 to say, okay, I got it, I've dealt with it, now clear that data from your form so that you never send me that data again.
Is this it?
Unfortunately, that's like speak. No, it's really small, so there's no way I can actually read that.
Oh, no. Okay.
Oh, look at that. There you go. I got to stop talking. And you have to talk to make that screen active for me.
I have to. Oh, I see. No, you click on it. No. You can click on it. In the bottom, you can click on it. Yeah.
Because when I talk, I just see my face.
Sorry, I just did this. No, but if you click,
forwards,
if you click on the bottom.
Yes. Okay, I see it.
Do you get it?
Okay. Pet peeve?
Yes.
Stop going to non-authoritative sources for descriptions of stuff.
Okay, I know. I just did. I saw HTTP statuses. So.
IANA status registry.
There we go.
And the reason I say that is I have seen fairly well-established organizations with lists of status codes with descriptions that are blatantly wrong. Cough, Mozilla, cough.
Okay, I see it.
They're fixed now, by the way. Mozilla fixed up all of their stuff.
Okay, hold on. Hold on, it's coming back to you. Hold on. Let's do this. Let's correct our wrongs because we can't edit. How's that?
Yeah, well, that's 7231 where it is actually defined. Yes,
it was there. It just came back. Yeah. Okay.
Yes, but the easiest place is just to start at the registry and then go from there. But yes, that's where reset content. Let's see if I described it correct. The server has fulfilled the request and desires that the user agent reset the document view which caused the request to be sent to its original state as received from the origin server. And believe it or not, I've actually used this status code in building a desktop client app. It was quite a handy status code to indicate that, the user said, yeah, I want to submit this, and then I'm done with it. I'm finished with this document. And the server would send back and say, okay, yeah, everything was good. You can now get rid of that. So there we go. You had a topic that you wanted to discuss, Glenn.
Yes, so the first one is going to be poking. So I'm going to poke. What's up with the HTTP hand puppets?
How did that come about?
I was on Twitter.
That was Khalid who suggested it because.
What was that about, though? We got to bring this out into the open.
It was an original tweet from Eric Lawrence. Oh, I think it was. Oh, yeah, that was. They were making fun of me. Eric Lawrence and the guys from Edge were making fun of me because Eric Lawrence had said that he had changed the user agent version of some tool to be like 1.7b, and it was breaking clients because they were parsing the version to a float.
Right.
And I said, does nobody read specs? Because the spec quite clearly says the version is just a token. It can be letters, it can be numbers. And they were laughing at me because I was saying that, why does nobody read specs? And I pointed to the specs, and Khalid said,
right,
well, maybe, if there was like animations and hand puppets that people would actually read the specs.
Right. So let's get something clear. There's a difference between the average user of a framework and the framework authors. And especially if it is, like a framework like ASP.NET, I think you have no excuse. If you're not reading the spec, you have no excuse. If you're going to do parsing logic, you need to basically look at what are the constraints of the value that you're parsing, period.
Yes.
So I'm with you.
Completely agree. Yes. And the thing is, there was other comments on that thread that basically said, oh my goodness, you can't possibly change a character in the user agent because it will break all kinds of things. And this is because people are looking at HTTP headers and treating them as opaque strings when they're not opaque strings. You have to look at the structure of how the HTTP header is defined and recognize that it's a list of products and comments with a decreasing significance of priority and so on and so forth. And I mean, we've run into situations with auth headers where people have not put a scheme and then the parameters of the scheme, they just put a value.
Right, which is wrong.
We had tooling that broke because it was respecting the spec.
Yes.
And then I've seen other tooling that broke because people put colons inside the auth parameters, and you're not supposed to put colons inside auth parameters because somebody comes along to an HTTP header and they split on the colon because that's the only place it's supposed to split, and it ends up splitting into multiple different tokens because there are colons in the auth header.
Right, or encode it. You can encode it.
Yeah. Which is absolutely fine because then it falls within the valid set of characters. Yes. So it's I realize these specs are arcane and they're not the easiest things to read, but this is why you need to actually either use tooling from somebody who did read the spec, or read the spec yourself, which is why I tell people never to use string concatenation to build URLs, because believe it or not, building URLs is actually really quite tricky. There's a lot of really funky character rules within URLs. So use a URI template library to build them for you, and then you don't have to worry about it.
There's a acronym that comes to mind that starts with R and ends with M. RTFM.
Oh, well, yeah. But
I mean, and particularly if you are a framework author.
Yes.
I mean, these specs are there for a reason. You are building something based on the spec. You start with the spec. You use the spec to help you define how you're going to do the implementation. So I'm right with you. I got you back on this one.
Okie dokie. Okay.
I have no hand puppets, but I've got you back on this one.
So that was. Can you imagine like a whole show with just hand puppets, like doing the talking about HTTP? That would be rather entertaining.
Right? Well, a different hand puppet for each status code would be kind of interesting. You bring out the hand puppet that talks and says, "Hi, I'm 201. This is what I do."
We could have the Rastafarian hand puppet and the GraphQL hand puppet.
Nice. And the hypermedia hand puppet.
It's like the personas. We have
the hypermedia. You know what? We need to get these hand puppets, and when certain topics, I honestly think we should do this. We're gonna have to talk about this. I think Khalid is really on. I'm not kidding. I think we should have like hand puppets, and when certain topics come up, you just bring up the hand puppet, right? Like we have the GraphQL hand puppet, and we bring that up.
Our poor RSS readers.
So, in interest of not wasting any more
time. Yeah.
Yes, I do have something else I want to talk about, and I want to thank Asborn for pointing this out, and I hopefully pronounced his name correctly, Asborn. So, Netflix has come out with something pretty interesting that they announced called the Netflix Conductor. And so the Netflix Conductor is there's been a lot of orchestration engines out there, and Netflix has, a massive amount of work that they need to orchestrate, and it is basically, and we've moved to this microservices world where, it's no longer a monolithic server or a few set of servers that are doing work. And Netflix has been one of the companies who's really been at the forefront of pushing this microservices type architecture, and they have like thousands and thousands of microservices that are handling different things, so they needed a way to coordinate between them. So they created this thing called Netflix Conductor. And what's interesting about it, I think, from an HTTP perspective, is that one big thing about it is stateless. So you have this concept of a workflow, which is like a template of work that needs to get done, and you have state. And they have this concept of a coordinator, director, what did they call it? Hold on a second here. I'm trying to scroll on the Chrome view. The conductor. They have this concept called the conductor, and what the conductor does is it looks at this DSL, which defines the execution flow, and it looks at the state, combines the two, and then it basically sends that over to like an executor to do some work. But what's different about it than traditional models is everything is stored. The application state contains both contains the information about what the progress is, and all of the state for the execution of the workflow is stored there. And so when the conductor gets it after some work is done, it basically matches up the template of work that needs to get done, the work that was actually done, and then it decides the next step to go. Now, some people had questions because remember I talked a bit about hypergoal in the previous episodes, and some were asking, and Asborn, I think, was asking this, like, oh, is this like hypergoal? In some ways, it is from a stateless perspective, in the sense that one of the key things about hypergoal is a similar idea, this idea that there's no one central place which is persisting the state of this workflow that is executing. And both have a concept of a workflow. The difference, I would say, between the two is that this still is and it's not to say it's wrong, it's just different. And this is still a server-centric orchestrator. It's a stateless orchestrator, which is what this conductor model is, but it's making the decisions about, the based on the workflow, where to go next. And it is encoded into the workflow, essentially. Whereas
the state of that workflow is on the server, right?
Yes.
Whereas in hypergoal, as I understand it, the state is on the client.
State is on the client. I mean, this could work that way. I guess you could try to argue that the conductor is like a client telling something else to do work, but it's a stretch, right? Yeah, so that's the way I see it, as completely different, because the idea of, in hypergoal, we have this concept of an agent that is in the middle of the client. Like, there's the client, and the agent is there basically as a guide to give options and say, the agent knows here's where you're trying to get to because the client expressed it. The agent is then saying, okay, I know where you're trying to go. I know where you are. Here's the choices of things that you can do based on where you are, which is where the hypermedia of hypergoal comes in, which get returned to the client. And then the client makes that decision. And there can be n number of clients. Whereas in this model, the number of conductors is probably pretty small. Like, I mean, it's possible to be shared because of the fact that it's stateless. But imagine you have millions of clients that are each running different types of workflows. The other side to it, I think, is that this feels like more of a closed system, in that the different participants that are executing the different tasks have a lot of pre-knowledge. They've been wired up. There's there's a knowledge there. There's a shared knowledge
Yeah.
there. And in the case of HyperGoal, it was trying to address, well, what if there wasn't? Like, how can we deal with an infinite number of systems, but bring them together into a workflow where we can, because there's still steps that need to be performed. There's still state that needs to be managed. That's the same. But, you know, how can we make it so that the things that are performing the work don't have to know that they're participating as part of some workflow? They're just processes that need to run. And that was, now granted, one difference between these two things is HyperGoal, barring a few experiments, is still very much in the realm of theory and, you know, like, you know, proving it on a whiteboard of sorts. Whereas this is something that's actually running at scale and has been running for a year. But the one thing I think that's really important, and why I also wanted to bring it out, aside from differentiating between HyperGoal and this, is the level of scale they were able to achieve by being stateless. That's a key aspect of what they call out if you read up on this conductor model, is how that statelessness has allowed them to achieve massive scale, because there's just no database in the middle. There's no concurrency kinds of issues where two are trying to update at the same time. Everything is really encapsulated in this stateless model. And I think that's pretty awesome.
Yeah,
that they've done
it'd be interesting to understand more the difference between that and like Microsoft have the Logic apps, which is kind of their evolution of the original workflow engine, and it's now offered as a service. So there are, you know, hundreds of thousands of customers, potentially, I don't know, millions of customers who are going in and creating their own little Logic apps, which are process flows, where you say, take this data from here. If some data appears in a queue over here, then take it and then go do this and call this API and take the result from here. And
so I would imagine the first thing I would think of, which would possibly be a differentiator, but I don't know enough about Logic apps, is the stateless aspect. Does Logic apps, you know, does that state itself live outside of being persisted somewhere? Because that's really where this is solving a huge bottleneck, in the sense that that state is traveling around. It is not actually stored in some kind of MongoDB database store or whatever. And I don't know enough about Logic apps to know if that's really how that works. Like, if you remember, like Windows Workflow Foundation back in the day, that had a notion of like state persistence and things like that. But that very notion of persistence would be going out to some store somewhere to store that data, as opposed to it being completely stateless.
Well, that was optional, right? You could persist out the state so that the thing could go to sleep and then get woken up at some other point in time. I believe Logic apps tend to be more dynamic in that they are triggered by some external event, either an HTTP incoming call or a blob appearing in a blob storage folder or a message in a message queue. They execute to completion.
But what happens if they didn't complete? Like, what happens? Like, how do I know at any point in time, if I'm in step A and then I go to step B, where is the information stored that says I'm now at A, I'm now at B, I'm now at C?
That I don't know.
So that would be I think that would be a thing that, at least here, is one of the differentiators that they've identified that has allowed them to get to this massive scale. But I
mean, they are going to have some state to know what state their workflow is in, right?
Sure,
I mean,
but
it may not be addressable. It may not be persisted.
No.
There's got to be some failover mechanism.
Oh, sure. But if you look at, for example, like, and this is one of the things we pushed in HyperGoal, is the fact that that state moves around. That state constantly moves. Like, if you look at, like, the way HyperGoal works is like that state gets sent, some work gets done, the result of that gets packed into that state continually moves around rather than being persisted into a central store.
Yeah, okay. Well, I mean, I'm not sure. The interesting thing is the characteristics that it provides, as opposed to necessarily the implementation details of where it is. So.
Oh, yeah. No.
Anyway, definitely an interesting piece of tech to keep their eyes on. Netflix are famous for doing some really interesting things architecturally. They have pushed the Experience APIs as a way, also called backends for front ends. They've done all sorts of clever stuff.
Yeah, and I think another really cool thing is the part I just highlighted, which is they've open sourced this.
Interesting.
So, yep. So they've open sourced this, so we can instead of speculating how things work, we can go look at the source and figure it out.
Very cool.
I don't know if we could do that for Logic apps, but we could definitely do that for this.
So we are going to have to put on hold the planned conversation about persistent connections and all of the theory behind that, and all of the interesting conversations about circuit breaker technology and load balancing and all of that good stuff for another episode, because we don't have enough time anymore because we chatted on this stuff, which is cool. Do you have any final announcements to make as to upcoming things that are of interest? Maybe conferences you're going to or stuff like that?
I'm pretty conference free right now, and I'm actually happy about that because I had a crazy amount of conferencing in the last year. So no, I'm sitting pretty tight. What about you?
Well, I submitted to NDC Minnesota, so I have all of my fingers and toes crossed that I'll be accepted for NDC Minnesota. First time NDC is coming to North America, so that's going to be very exciting.
Yeah, cool.
And planning is started for API Strat, which will be later on in the year. Not even nailed down the destination yet as to where API Strat will be. It's like, where in the world is API Strat this year? So
I will track it. I definitely really enjoyed that event, so that would be one I'd be interested in going to again. All right.
So there we go. Another episode. I will try and get this one downloaded and pushed up to the RSS feed. And maybe one day I'll even get it appearing in the iTunes store. And
maybe we'll get our blog updated, which I take full responsibility for. But now I'm trying to spread that load with you.
We will tag team.
We want to catch it up.
Yes, indeed.
Awesome.
Well, thank you for joining. Thank you for listening. And we will see you again next time.
Take care, everyone.